All right, this is the third video on electron configurations. And here we're going to look at a sort of shorthand notation called the noble gas electron configurations. So these noble gas electron configurations stem from the fact that chemists are inherently lazy. And we don't want to write out more of these electron configurations than we have to. And so what we do with noble gas configurations is we note that if I have any element heavier than neon, or with a greater atomic number than neon, the electron configurations always start out as 1s2, 2s2, 2p6. Or if I have anything with an atomic number greater than argon, the electron configurations always start out 1s2, 2s2, 2p6, 3s2, 3p6. So rather than writing all that crap out, what we do is we write the noble gas symbol in brackets to replace all of those innermost electrons. And so the noble gas that we pick is you find the element that you're looking for and then find the closest noble gas that has a smaller atomic number. So for example, if we do arsenic. So arsenic is right here. So when I look for the noble gas to pick, right, essentially I just work backwards numerically. So arsenic is 33, so I go back until I get to argon. And so argon is the closest noble gas to arsenic that has a lower atomic number. So I'll replace all of the inner electrons of arsenic with the symbol for argon in brackets. And so this argon in brackets stands for 1s2, 2s2, 2p6, 3s2, 3p6. It's just a whole lot easier to write argon in brackets than all the other stuff. So then I just start with argon and look after that. So the first electrons that I come to after the argon core is 4s2. And then next I have the 3ds, and they're full, so it will be 3d10. And then now I get to where arsenic is, and arsenic is 1, 2, 3, so 4p3. All right, so much easier than writing out the full electron configuration. Now, if I ask for the full electron configuration, you have to write the whole thing out. If I just ask for the noble gas configuration, then you can use this shorthand. Let's look at one more example. Okay, and I should have said here noble gas. I want the noble gas electron configuration for Pu, that's plutonium. So I look and I find, all right, here's plutonium down here. It's one of the actinides, number 94. So the noble gas that I'm going to use for plutonium, I work back numerically, 94, 93, 92, etc. And so I see that the noble gas that I'm going to use is radon. So I'll start my electron configuration by writing radon. Then the next electrons that I come to are going to be the 7 s's, and they're full, so 7s2. Now note that the lanthanides and actinides are a little bit weird. So after element 88, I come to element 89. And notice 89 isn't in the F block, it's still in the D block. But there's just one, because after 89, number 90 jumps down to the 5 Fs. So what happens is this 89th electron goes into the 6 Ds, and then 90, 91, 92, 93, 94 go into the 5 Fs. And so there's 1, 2, 3, 4, 5. So it's going to be 5F5. All right, so the lanthanides and actinides are a little bit unusual in this way, right? And remember that the Ds are always 1 less than the row they're in, and the Fs are 2 less than they're in, right? So I'm in the 7th row, but it's the 6 Ds and it's the 5 Fs.